So the first thing we want to do is we want to make sure that our mode is in polar. Now most of your modes are probably in function, but you want to make sure that's in polar. It might be in parametric if you were just doing the parametric section. So we go down and highlight polar. You want to make sure you're in radian. Basically, in all in calculus, you want to do it with radians. Now, generally, when you're graphing sine function, cosine functions, and anything that deals with thetas, you can usually get away with doing degrees, but then like the graph ends up getting messed up. Instead of going from 0 to 2 pi, you go from 0 to 360. You need some really weird windows. And it really just does not work well in radians. So, in degrees, sorry. So make sure you are in radians. Now, once we're in polar, press y equals, and we can type in our equations. So we're going to check r equals 4 just to make sure that this works. So we type in 4 for the r, and we graph it, and we get that circle that we wanted to do. Now go back to y equals, you're going to realize there's not really a spot for me to put theta equals pi over 4 in here. I could do the 2 theta, and if you press x, x becomes theta now all of a sudden. You notice that or not, but so it's the xt theta n. So when you're in the right mode, this button will do the right character for you. Let's look at the graph here. Now we see that it gets really big really fast, so let's mess with it a little bit. And let's go 0.5. I want to show you something really quick before we get into the whole graphing number 7. So we hit 0.5 and we graph, and it stops. But there's nothing to stop theta. Well, what stops theta is in the window. So in the window, it gives you a theta minimum, and it gives you a theta maximum. So this is what will allow you to go negative angles if you wanted to. But if you wanted this to go around twice, you want to go around 4 times, or 5 times, or 8 times, let's say I want to go 12 second pi, which will bring us around 6 times, and give us a much neater spiral. Might be outside the window that we need anyway, but that's how I can make these go a little farther. So they automatically stop at whatever value they have in the window, which is different from rectangular, because rectangular doesn't have a maximum. It just graphs whatever it wants to. So back to the question at hand, number 7 here. Go to y equals, and we're going to do 2 cosine of 4 theta. Now, it depends on what the shape is. It might keep going. It might really end up messing up the screen if we go past 2 pi. And we left this at 12 pi. So let's just graph and see what happens. Alright, so we got something really, really nestled around here. Now let's think about the size of this. Well, cosine is something that goes between -1 and +1. And we're multiplying by 2, so I really want to make my window go from -2 to +2. This graph can't take on any values larger than that. So let's go -2 to +2. And the scale's fine. Y minimum, nope, too far. -2 to +2, maybe. And a couple things. One more other thing here, the step. This just talks about how often it plots. If you want to get a much cleaner picture, make this number smaller. If you want to graph faster, if you're going to try to erase somebody for some strange reason, make it larger, but it ends up making a jagged picture if that number is kind of large. So if you're right, go to graph, and we get basically a flower. Now, if you were to, let's go back to our window here. If you notice my calculus is still thinking here, I'm going to make my step even smaller. And one of the things that kind of happens when it's really small is you actually see it graphing. And that one kind of just jumped up on us. And the other thing I'm going to do is I'm going to go over here and make this into the little dot that you sometimes see. So you can see it tracing along here. So we'll see what happens after you get around once. Oh, I made that a little bit too small. So it's plotting, but it's just going by too fast. So I'm going to break this. We're going to go to window, not go 0.001. Let's go by 0.01. That might still be kind of slow, but let's see what happens. Yeah, that was a little slower than I'd like it to be, but you can see it plotting, and it does do a nice graph. So even though it probably would have been just fine to watch it. The bad thing is it was already 0.1, so alright, anyway, let's graph it, but we'll see the little dot. So you see it wrap it around here. And it keeps going. And then at some point it gets back to 2 pi there, and then it just keeps wrapping around. Alright, so polar slope. We know that r is some sort of function of theta, and y is r sine theta, and x is r cosine theta. So we want to find dy d theta, dx d theta, and use them to find dy dx. So we want to find slope, just normal rectangular slope. So what we're going to do is we're going to derive the slope formula. So we want to find dy d theta, so find our dy. So we unfortunately know that r is a function of theta, so this needs a product rule. R prime sine theta plus r cosine theta. So that's dy, and then we're going to put that over dx. And it's one of those things that you just wish that you didn't have to do a product rule here, but you just have to. And once you realize it, it's not that bad. So dy dx, you define y to be r sine theta, you find x to be r cosine theta, and then we do dy over dx, we get this fun thing. So r prime cosine theta minus r sine theta. Couple product rule. Now, I would not go about memorizing this formula. I would go about memorizing this process to do the formula. Now, when we want to find the horizontal and vertical tangents, now, thinking about horizontal tangents, that's when your slope is 0. So if I look at this fraction here, if the numerator equals 0, here we have horizontal. Because 0 divided by a number is 0, and horizontal lines are always horizontal, flat, cross, sideways. If I want a vertical, that's when I have no slope, undefined slope. And that happens when you have the dx to be 0. So that's what you have for vertical slope. So to find the horizontal and vertical tangents, to find the horizontal, you set dy equals 0. On the vertical tangent, you set dx equal to 0. Now, dy is this whole fun thing, dx is this whole fun thing, and again, I wouldn't try to memorize this, I would have to do it each time. So I want dy equals 0, so my first step would be to say y equals r sine theta. So y equals cosine theta sine theta. So then dy equals negative sine theta times sine theta, so sine squared theta, and then, so that's the derivative of the first, plus, and then we do the derivative of the second, cosine squared theta. So this would be horizontal when it equals 0. Add over your sine squared, and you get cosine squared theta equals sine squared theta. Now my question for you is, how good are you at solving your trig equations? Now, there's a lot of different ways of doing this. You could substitute 1 minus sine squared in for cosine squared. That's one way of doing it. Group them, factor. That will work. The easiest way is just taking the square root of both sides, and you're just going to say cosine of theta equals plus or minus sine theta. You could put plus or minus on both sides of this equation, but it doesn't really matter too much. You're just looking for where the x value is equal to the y value on your unit circle. So where's x equal y? And it's plus or minus y, so I don't even really need them to be the same sign. That's all the power of 4. So currently we have horizontal at x equals pi over 4 plus or minus, now it's all the pi over 4s. So a lot of times you're going to find the horizontal and vertical tangents of this on 0 to 2 pi. A lot of times that happens, sometimes with brackets, sometimes with non-brackets, but you really don't want to think about horizontal and vertical tangents at endpoints because it's hard to see what happens after them. So a lot of times you won't really be looking too closely at the endpoints. Even though sine and cosine, they do extend past those endpoints, so that makes it a little bit of a tricky question. So, one way or the other, we got pi over 4, 3 pi over 4, And we're just going to keep to 0 to 2 pi right now. 5 pi over 4 and 7 pi over 4. Alright, so we have our horizontal. Bad news is we're only halfway there. We got to find our vertical. So our vertical is dx is equal to 0. So I'm going to steal this from up here. We can do it the same way we did it here, but we'll still arrive at the same thing. Here's our x, do our derivative. So, I don't know if you want to do it like steal it from here. I probably wouldn't actually think about this. So you could steal it from here, which would be kind of trying to go to the step, but just write x and find dx d theta. So x equals r cosine theta. So x equals r, which is cosine theta, so cosine squared theta. So dx equals, and it's dx d theta, technically. Same thing over here, dy d theta, and that's true for both of these, to cosine theta sine theta. And we're setting this equal to 0. Well, this equals 0 when sine equals 0 and cosine theta equals 0. Well, sine theta equals 0 at 0 and pi over 2, but we're not counting those, so this really doesn't give us much. Cosine theta equals 0 at pi over 2 and 3 pi over 2. Now, one of the things that you're going to have happen here is sometimes these numbers are going to overlap. And what that'll end up being is basically cusp in the graph. And if that happens, you don't include them in either of them. A line can't be both vertical and horizontal at the same time. It just doesn't work that way. Well, good luck with the vertical and horizontal tangents. The process is exactly the same thing. For horizontal, set dy equals 0. For vertical, set dx equals 0. Solving these trig equations is going to be the fun part about it. Doing the derivatives, that should not be a big issue. The question is, can you solve these two equations? And these are some of the tame ones. They're going to get a little hairy. So in trig equations, you get a couple things you want to do. Mainly, a lot of them are going to reduce down to factoring. You're going to want to get one function if you can, either sine or cosine, which we could have done here by moving these into sines, but basically you're going to end up factor like we did here. They're already factored, set them equal to 0, and then set equal to 0, and hopefully you can solve. You're going to get a lot of interesting trig solving problems in this section.